Given the following algebra tile diagrams, write the expressions and simplify if possible. And by simplify, we mean get rid of zero pairs. So this expression here, we can write as 2x squared, because the big tiles are x squared. And then we have these three tiles here, so we're going to, because they're different, we're going to count them differently or show them as plus 3x's. So there's 3x tiles there. And that cannot be simplified. Here we have x squared, 1x squared. We have 3x tiles, so 3x. And then we have two white little square tiles. Well, those little square tiles are ones, and we're going to take away those two tiles. So we have minus 2. Here we have 2x squareds plus 3x's. And below we have, we're taking away, we have a minus x squared tile. We have a minus x tile, so that rectangle is x. This big square is x squared. And these little ones are just ones. So we're just going to minus 4 ones. Because there are some like terms here, we can group them together. And those are zero pairs. Those cancel out. One negative and one positive will cancel out. One negative here, one positive here will cancel out. So when we combine the like terms, we have 2x squared, and we're going to take away an x squared. So we have one positive x squared here. 3x minus x is going to end up with 2 positive x's. And we can see those 2 positive x's here. And then we have the 4 ones left over. Okay, so I'm just going to color code this. So there's my x squared. Here's my 2x's. And this represents my 4 negative ones. Here we have, I'm just going to count the positives first, so I end up with 1x squared plus 4 x's plus 2. When I look at the negative tiles, I have 2 negative x squared, so I'm going to minus 2x squareds. I have 1 negative x, so I'm going to minus an x. And I have 6 negative 1, so I'm going to minus 6. When I group together my like terms, okay, I have 0 pairs here, those cancel. I have 1x squared and 1x squared, so those cancel. I can group together 2 negatives and 2 positives, and those cancel. So what's left over then would be 1 negative x squared. So x squared minus 2x squared leaves me with negative 1x squared. I have positive 3x's. So 4x's, and take away 1 gives me 3x's. I have minus 4 ones. Plus 2 ones minus 6 ones gives me negative 4 ones. And again, I'll just highlight the parts here. There's my negative x squared. My 3x is here. And my 4 ones are these parts here. So why can we not combine x with 4x squared? X's with x squareds, basically. Well, when we look at the picture, x squared and x's are different. They're just different shapes. We cannot combine things that are different. So that's the basic explanation of this. X squared and x are different shapes. And they cannot be counted together. So if I look at x squared, I have, a big X like that, and X would just be a rectangular box. These are different shapes, okay, and they cannot be counted. You cannot consider them the same thing, so we cannot count them together. We cannot combine like terms. These algebra tiles are based on area. So to get an area of x squared, we have a length of x and a width of x. To get an area of x, we have a length of 1, a width of x. So these algebra tiles are based on area. So we want to make sure that we have a clear idea of what the area model for multiplication is. So without a calculator, if I want to multiply 23 times 12, what I can do is I can break it up into our box multiplication of 20 plus 3, 10 plus 2. And we can see how when we break up pieces in addition and how we combine them with multiplication, how these parts interact. So 20 times 10 is 200, 3 times 10 is 30, 2 times 20 is 40, and 3 times 2 is 6. And we add this all up, we get 276. So when we multiply 23 times 12, the answer is 276. If you're not sure, you can always try in your calculator and you can confirm that that's the case. And the reason is because this area has to be conserved. Whether we break it up into have one whole length of 23 or break it up into 20 plus 3, the area stays the same. When we multiply 24 times 31, I'm going to maybe do this, 30 plus 1, 20 plus 4. So this is 600. I get 120 here, 20 here, and 4 ones here. Adding up these areas, 600, 720, 740, 744. So 24 times 31 is 744, and I can see how the pieces are generated when I have these plus pieces mixing with the multiplication.